All right, let's talk about special right triangles. Now, special right triangles occur when we can find patterns in which to easily solve solve right triangles. There are two cases, one of which starts out with an equilateral triangle. Now, an equilateral triangle, we already know two things. One thing is that all these angles are going to be the same. The second thing is that all the sides are the same. That's just by definition of an equilateral triangle. Now, what I can do is if I drop an altitude from one of the angles, what it does is it first of all splits this angle in half, and it also splits this side in half. So these are very important things. Let's just, for computation's sake, let's name the right side to be just 1 unit, and that'll come in handy later. So if that side is 1 unit, then by the fact that the altitude splits the base in half, we can say that this side down here is 1/2. Now, I got a little ahead of myself. So if this angle is 60 degrees, and this angle up here got split in half, then this angle up here is now 30 degrees. So this is what we will refer to as a 30, 60, 90 triangle. It is a right triangle because one of the angles is 90 degrees. Now all we need to do is find the length of the altitude, and to do that we use the Pythagorean theorem. The Pythagorean theorem says a squared plus b squared equals c squared, where a and b are the legs and c is the hypotenuse. In this case, I'm going to say that a is 1/2, b will be our altitude, and c is going to be our hypotenuse, which is 1. And we want to solve for b. So what we're going to do is I'm going to square everything. 1/2 squared is 1/4, plus b squared equals 1. This should be squared. 1 squared is just 1. I'm going to subtract 1/4 from both sides. And this gives me then that b squared equals 3/4. Now, in order to get b by itself, I take the square root of both sides. The square root of b squared is just b, and the square root of 3/4 is the square root of 3/2. So what this tells us, if we put this back onto our triangle, that this is the square root of 3/2, that seems like somewhat complicated, but we can think of this in a different way. If this hypotenuse right here is 1, then the small leg is half of the hypotenuse. Now, since we're already talking about half of the hypotenuse, this 1/3, this square root of 3/2 can be written as the square root of 3/2 times 1. No, can't be written like that. And I can't erase that either. It can be written as the square root of 3/1 times 1/2. So it is the square root of 3 times the 1/2. So that what we will do is, if the small leg is half of the hypotenuse, the long leg, which is the altitude, is going to be the small leg times the square root of 3, because we already have the square root of 3 times 1/2 is square root of 3/2, which is this altitude. Now let's use these in some examples. Let's say that I have a 30, 60, 90 triangle, and I want to draw one. We'll put it on its side this time, just to change things up a bit. So we are being told that this is a 30, 60, 90 triangle. Ugh. Bad. That's 30 degrees, this is 60 degrees, and this is a right angle. So if we start off saying that, let's say that the hypotenuse is 4, then the short leg is going to be half of the hypotenuse. So the short leg is going to be 2. Now the long leg is going to be the short leg times the square root of 3, based off of this diagram. Remember that this 1/2 down here, if we multiply that by the square root of 3, we get the square root of 3 over 2. So that gives us the long leg. So if the short leg is 1/2, or the short leg is 2, then the long leg is going to be 2 times the square root of 3. Now this is the exact answer. If I wanted an approximate answer, I would put that as a decimal. And the reason decimals are called approximate is because we have to round them. 2 times the square root of 3 is an irrational number. It is a non-repeating decimal, and it will go on forever. If we round it, we lose all the numbers that we cut off. If I just tell you that it is 2 times the square root of 3, you know you will be able to compute the decimals for as far as you need or want. So 2 square roots of 3 is the exact answer. So if we do another one, and this time, of course, we'll change it up. This will again be a 30 degree, 60 degree, 90 degree triangle. But this time, let's say that we know the small leg to be 4. If the small leg is 4, it is half of the hypotenuse. Because remember, this is half of an equilateral triangle. It will help you to remember what part is a half and what part gets multiplied by the square root of 3 and what part is the whole unit, if you can realize what part of an equilateral triangle this is. So if the short leg is 4, then that is half of the hypotenuse. And the hypotenuse would then be 8. So if the short leg is 4 and the hypotenuse is 8, then we need to find the long leg still. The long leg will be the short leg times the square root of 3. So it will just be 4 square roots of 3. And just for kicks for this one, let's use the Pythagorean theorem to see if we can get the same answer. So if the hypotenuse, we want to find the altitude, which is the long leg, so the altitude squared plus the other leg, which will be 4 squared, equals the hypotenuse, which is 8 squared. So I'm going to square everything. A squared can't be squared, or any more than just writing a squared. 4 squared is 16, and 8 squared is 64. So if I subtract 16 from both sides, I get a squared equals 64 minus 16. Cancel that. That's a 5. Then that's 14. 14 minus 6 is 8. 5 minus 1 is 4. So this is a squared equals 48. And so to get rid of the squareds, I take the square root of both sides. And it leaves me with a equals the square root of 48. Now, the question is the square root of 48 the same as 4 square roots of 3? Well, let's do a prime factorization of 48. And most people recognize this as the tree of factors. So 48 can be divided by 2, which gives me 24, which can be divided by 2, which gives me 12, which can be divided by 2, which gives me 6, which can be divided by 2, which gives me 3. So this can be now written out as the square root of 2 times 2 times 2 times 2 times 3. Now, by properties of square roots, I can break this up as the square root of 4 times the square root of 4 times the square root of 3. And I said square root of 4 times the square root of 4 because these two 2's become a 4 and these two 2's become 4. So now the square root of 4 is 2 and the square root of 4 is 2, so 2 times 2 is 4 square roots of 3, which is the answer that we first came up with. So using the shortcut, it is specifically this much easier. Actually, even more. that much easier. Instead of doing the whole Pythagorean theorem. And if you can't remember the shortcuts, by all means, use the Pythagorean theorem. That's fine. It's just easier and shorter to do it this way. And once you get into trigonometry, and maybe you already are, then you should know this already, just by using sine, cosine, and tangent, which we will get to later. Okay, the second shortcut is for, no, we're not going to go to the second shortcut. We still have another example to do. So let's say we've had a triangle where we're given the hypotenuse. We've had a triangle where we're given the small leg. So let's have a triangle where we're given the long leg. So let's say that in this case that the long leg is 4, since that's the number that we've been using. And this is 30 degrees, not just 30. So in this case, to go from the short leg to the long leg, we multiply by the square root of 3. To go backwards, we're going to do the exact opposite, and we are going to divide by the square root of 3. So the small leg is now 4 divided by the square root of 3. However, I don't like how that looks because there's a radical in the denominator. So I'm going to multiply it by the square root of 3 over the square root of 3, which gives me 4 square roots of 3 over 3, and that is going to be my short leg. Now, this being the short leg is half of the hypotenuse. So what I'm going to do is, normally, to go from the hypotenuse to the short leg, we would divide by 2. Now, to go backwards, we do the exact opposite, and we are going to multiply by 2. So 4 square roots of 3 over 3 times 2, 4 square roots of 3 over 3 times 2, this will be times 2 over 1, equals 8 square roots of 3 over 3. Now, this one would be, thinking of possible other ways right now off the top of my head. I can't think of any other ways to do this problem without using trigonometry or without using the shortcuts. Because we need to know the relationship between the sides of this special triangle. And it all comes from way back here where we started with an equilateral triangle and we dropped an altitude. We dropped this altitude and we said that this hypotenuse is 1. Since the altitude splits the triangle in half, this side is a half. And then we use the Pythagorean theorem to see that b equaling the square root of 3 over 2 equals the square root of 3 over 1 times 1/2. So it is the square root of 3 times this 1/2 side. So whenever we find the long leg, we are simply taking the small leg and multiplying it by the square root of 3. All right, so that is the 30, 60, 90 triangle, and the next triangle that we're going to do is a 45, 45, 90 triangle. Now, a 45, 45, 90 triangle is, as you might guess, it is an isosceles triangle because these two angles are 45 degrees. And if two angles are 45 degrees, their opposite sides have to be equal. And in this case, we are going to, again, we're going to say, for proof's sake, that the hypotenuse is 1. Now, the hypotenuse being 1, we need to find these two sides. And we are going to, again, use the Pythagorean theorem because we have a right triangle. And the Pythagorean theorem works with right triangles. So we have two sides. We don't know what either of them are. But whatever it is, it equals 1 squared. And the reason we can say, well, I can have side squared plus side squared, there's still only one variable here. So we need only one equation to solve for this one variable. In doing so, I end with 2s squared equals 1, just combining like terms and squaring the 1. If I then divide both sides by 2, these 2's cancel out, and s squared ends up equaling 1/2. Now, all we do, we take the square root of the s squared and the square root of the 1/2, And the square root of s squared becomes s, and the square root of 1/2 becomes 1 over the square root of 2. Now we don't, again, this is not how we like things to look because there is a radical in the denominator. So once again, I'm going to multiply this by the square root of 2 over the square root of 2. And it now becomes the square root of 2 over 2. So same way with the 30, 60, 90 triangle, this is the same as the square root of 2 over 1 times 1/2. So what we're going to do is we're going to take, this tells us that we're taking half of the hypotenuse, this is half of the hypotenuse, and we're multiplying it by this square root of 2. Now, so that's good if you understand it there, but if you don't, let's do some examples, because examples are very helpful. So we have this 45, 45, 90 triangle. That is a given that this is 45 degrees and this is 45 degrees, and it's a right triangle. And we have to be given something else, because we can't just say, hey, give me all the sides, because all right triangles with at least 2 angles congruent are going to be similar triangles. So as long as the sides are in constant ratio, blah, blah, blah. Well, what I'm saying is we need one side. So let's keep with our 4, just for kicks. So let's say that the hypotenuse is 4. So we want to find the sides, or the 2 legs. Using the shortcut, I can take half of the hypotenuse and multiply it by the square root of 2. So half of the hypotenuse is 2, and I multiply it by the square root of 2, and I just have 2 square roots of 2. Half the hypotenuse, again multiplied by the square root of 2, is still 2 square roots of 2, and, well, that's it. We don't need the Pythagorean theorem, although it's great, and of course we need it to prove this. But in order to just do this problem by itself, that's all we need to do. Half of the hypotenuse multiplied by the square root of 2. Let's prove it. Let's put this into the Pythagorean theorem. Let's do it backwards, though. So in order to check, we're going to see if the square of the sum of the square of the legs equals 4. 4 squared it will have to be. So 2 square roots of 2 squared plus 2 square roots of 2 squared equals, this ends up being 4 times 2 plus 4 times 2, which equals 8 plus 8, which equals 16. And this is good because this is going to equal the hypotenuse squared. We'll call it c squared, which is c squared. Well, 8 plus 8 is 16. So c squared equals 16. So the square root of c squared equals c, and the square root of 16 does in fact equal 4. So this works. Now let's do a different side. So again, we'll start with a 45, 45, 90 triangle. That is given. This is 45 degrees. This one's 45 degrees, and that's a right angle. And in this case, let's say that we have one side being 4, because 4 is just the number that I picked. Okay, so the other leg, since this is a 45, 45, 90 triangle, the other leg has to be 4. Believe it or not, that is mathematically proven. It's outside of the fact that this is a 45, 45, 90 triangle. Using math, I can just say that other side's 4. That is one step. To find the other side, in order to go from the hypotenuse to a side, we would divide by 2 and multiply by the square root of 2. So to go backwards, we're going to do the exact opposite. We are going to, going backwards, we are going to divide by the square root of 2 and multiply by 2. And of course, they can be done in either order. I'm going to multiply by 2 first, so this is 8 divided by the square root of 2. And we can't have it in this form So we're going to multiply it by the square root of 2 over the square root of 2. And this then equals 8 square roots of 2 over 2. And this can be reduced into 4 square roots of 2. Now, since this is the last problem, why not check and use the Pythagorean theorem? We need to see if 4 squared plus 4 squared equals, we need to end up with 4 square roots of 2. For now, we'll label it as c squared. So this is 16 plus 16 equals c squared. 16 plus 16 is 32. So the square root of 32 is c squared. So that we see that c is, again, let us rewrite this using a factor tree. So 32 divided by 2 is 16. 16 divided by 2 is 8. 8 divided by 2 is 4. And 4 divided by 2 is 2. So we have 1, 2, 3, 4, 5 2's. So it's the square root of 2 times 2 times 2 times 2 times 2. So these two 2's drop down and become a 2 because it's the square root of 4, which is 2. These 2's become a 4. The square root of 4 is 2. And this last one is the square root of 2, which is c. So our final answer says that c is 4 square roots of 2. Oh, I don't know what I started writing there. 4 square roots of 2 is c. It's the exact same thing we came up with before. So in review, all the way back to the beginning, not that far beginning, with a 30, 60, 90 triangle, the small leg is half of the hypotenuse, and the long leg is the short leg times the square root of 3. And going backwards, all you have to do is do the inverse operation. So if we're starting with, say, the long leg, to get the short leg, you divide by the square root of 3. And then to get to the hypotenuse, you take the short leg and you multiply by 2. We're doing the exact opposite of what we started doing. And 45, 45, 90 triangle, I didn't write this in. Shame on me. That's the arrow key. So the square root of 2 over 2 are the sides. So this tells us that we need to divide the hypotenuse in half and then multiply by the square root of 2. If we want to go backwards, we divide by the square root of 2 and multiply by 2. Going from the leg to the hypotenuse, that is. And those are the two shortcuts for finding, well, not shortcuts. These are two special right triangles that give you shortcuts. We'll say it that way.